Hey everyone, it's Adam Smith from the field engineering team here, taking you through a quick video on how to install your hybrid Maia runner in Google Cloud Platform. Firstly, we start off setting up the hybrid runner within your Maia account. If you go to the tile on the left hand side which said runners and instances, click on runners, go over to the add runner button in the top right hand corner, and we're going to set up a Maia runner today. Give it a name, give it a description. We're going to pick Google Cloud as the cloud provider. There is only one deployment option, which is the Kubernetes deployment, which is GKE. You get an option to pick either the current or stable track. The current get updates once or twice a week. The stable gets updates once a month. Both are fully tested. Let's pick current. Click Create Runner, and that's everything set up for the runner installation in your Maia account. We just now need to deploy the runner within your Google Cloud Platform environment. There's lots of different tabs here, but we're just going to look at the deployment tab here. We've got access to the Maia documentation if we click on View Docs, and the main deployment documentation we're going to look at today is the one under here which says Google Cloud GKE deployment for Maia runners. If we go over to our Maia runners tab here, we also have access to the Terraform templates to deploy the Kubernetes infrastructure within GCP, as well as the Helm configuration. Let's just click on View Library to open up the GitHub repository. There is this drop down here which gives us access to different ways to actually clone this repository. We're going to pick the GitHub CLI, and in advance I've installed the GitHub CLI on my terminal. I'm using a Mac today, but you can also use Windows if you've got access to a bash or SSH prompt. I'm just going to click on copy the command here. I'm going to open up a terminal and then run the GitHub repo clone command to download the deployment library configuration to my laptop. For deploying the Terraform today and the Helm configuration, I'm going to use Visual Studio Code, but you can use any editing tool which you're familiar with. I'm going to navigate to the deployment library folder and also open up a terminal so I can issue the commands whilst also looking at the deployment library configuration. So if we go back over to the deployment library, there is a useful README which we can use to install the GKE Kubernetes infrastructure as well as the Helm chart configuration. We're going to go here to number 6, which is GCP GKE with Terraform. And if we just scroll down here, there's also some prerequisites which we need to do in advance. So you will need to make sure you've got these different CLIs installed and make sure that you're logged into the Google Cloud SDK before you issue any commands. So we're just going to scroll down further to go to the actual section for this installation. We've already cloned the repository and we're in the deployment library folder. Let's now just run this command to go to the relevant Terraform templates and also copy the example Terraform file to the Terraform tfvars file. On the left hand side, I'm just going to navigate to this file now and open it. And there are a couple of properties we just need to change. So first one is that I'm going to deploy to a specific project ID. So you'll need to also change this to match your project ID. I'm just going to keep this region, but there may be a specific region which you want to deploy your Kubernetes cluster to. And the name, you can change this, but I'm going to keep this default value. There are some other labels, but for this demonstration today, I'm just going to keep the defaults, as well as you can change the desired node count and machine type as well. For simplicity, I'm going to make this private cluster public, so I'm going to set this to false. If you are installing this in a production environment, you may want to choose to make this private cluster private. Other things to point out is we've also set up a Cloud NAT gateway as well. So we've set this property to true. There are some different examples for some configurations if you'd like to configure them. You can be very specific about the IP range you want to allow on the whitelist, but I'm just going to keep the defaults for today. So Going back to the documentation, the next 3 commands are just the Terraform init, plan, and then apply. So I could copy these, go over to the command line and run them all. When you run the Terraform apply, it will give you a summary of what infrastructure is going to be installed in your GCP environment. I'm going to type yes to accept the changes and approve them. And now it will go through and install the relevant infrastructure which you need for your hybrid runner installation. It usually takes between 5 to 10 minutes for this installation to complete. So I'm just going to fast forward now to the completion of the Terraform installation. Once the Terraform has completed, your Kubernetes cluster will be installed within your Google Cloud Platform, as well as any relevant permissions and also the service accounts which is required to actually connect to any of your resources. If you go over to Google Cloud Platform and log into your Kubernetes cluster, you will see your new cluster with a green tick to show that it's been successfully installed and is running. If we go back to Visual Studio Code, you'll also see there's some different outputs which you will need to use so that you can configure your nodes to connect to Maia. The first one we just want to have a look at is the auth command. So this just allows us to specify which Kubernetes cluster we're connecting to. I'd like to copy all this output to Notepad because we will need this later when we're doing the Helm configuration. If we go back to our README, it will take us through the next steps to configure the Helm configuration. So we just need to scroll up on this README, go to the first option here, Kubernetes deployment. We've already cloned the repository. We need to be in the deployment library to do this. If we just go up a few directories, copy this first set of commands to create the namespaces required. Now let's install the Prometheus monitoring. This aids the auto scaling within our Kubernetes infrastructure. And as we're doing a Google Cloud GKE installation today, we just need to copy this option here. This will now create a copy of the standard GCP Helm configuration as a new file called my-files.yaml. You'll see that it will be available here in Visual Studio Code, so we can just click on this. And then we've got some different options we need to fill in just so that our pods can connect to the correct Maia runner configuration within your Maia account. First thing to highlight is you can deploy different runner sizes. The standard one is small, and we're just going to pick small today, but there is also full documentation about the different runner sizes you can choose within the Maia documentation. The next section we need to configure is the OAuth client ID and client secret. Now we can get these credentials from our runner configuration within your Maia account. So let's go back over into Maia. We've got the credentials here. This isn't a one-time display, so you can come back to this if you need to configure this again later. We can just copy the client secret here. Next, we just need to configure the account ID and the agent ID in the region. So these are all available on the parameters tab. So we're going to get the account ID, then we're going to get the agent ID. My region is actually in the EU region. Yours may be EU or it might be US or Australia. It's actually prompted me cleverly in Visual Studio Code to change the default GCP project. So I'm going to use solution-architecture here. And there are other options you can fill in here, as well as your custom cert location, an extension library location for your Python scripts for additional Python modules, and also a driver location. Now, if you did need to fill these in, you would have to use Google Cloud Storage to store these artifacts, and you would just put a Google Cloud Storage location within each of these different parameters. We can see here we're pulling from the current branch if you needed to switch to stable, and also the repository URL which the pods will need to get access to. Scrolling down, we can see that there is also the service account email which we got from the Terraform deployment. So we can go over to here and copy that from the runner workload SA email parameter. And this service account is what you can use to grant access to different resources such as BigQuery within your Google Cloud Console. So once you've filled in these different properties, the next part is to install your Helm configuration. So if we go back to our README file, and there is this command to run just to install this. If you did want to change any of this later, you can also use the Helm upgrade command with the same parameters. So once this is run, you can then check on the status of your pods by running this git pods command and with the namespace Matillion. Now it will just take a couple of minutes for these containers to be created, pull down the relevant image and connect to Maia. So we're just going to fast forward to that part now. Once your pods have the status of running, they should have successfully connected to Maia. If you go back over to Maia and look at the overview status, we just need to refresh the tab here, and then we can see that it has the status of running. This means that your pods have successfully connected to Maia. The next step is to set up your environment to your different cloud platforms. I'm just going to take you through the steps just to connect to Google BigQuery, but you might be connecting to Databricks or Snowflake. I've set up a project in advance of this video. If we just go over to environments, click add environment and click credential type, we're going to go use runner assigned credentials. This just means that we're using the permissions which are assigned to the service account for the GKE cluster. We're going to click continue, just going to give it a name. We're going to select the runner which we've defined previously. We can pick owner or contributor access as a default environment access. In this case, I'm just going to pick owner. We're going to see what project IDs we've got access to. So I'm going to pick the project which we defined previously. And what we see is there's no data sets which are available. To get access to additional data sets, I'm just going to go over back to my Google Cloud Console. I'm going to find the service account which we previously defined. Just going to copy this and search it. And we see that it hasn't got any BigQuery permissions, so this makes sense why it hasn't got access to any data sets. Just for simplicity, I'm going to give it access to BigQuery using the BigQuery admin permission. You may want to use a more restricted permission. If you go over to Google Cloud Deployment, there is a list of the different permissions you can actually set. So we've got BigQuery here, and you can be more granular than just setting the BigQuery admin permission. I'm going to click Save here. It will take a couple of minutes for the permissions to reflect within Maia, so I'm just going to fast forward to that now. So back over to our environment configuration, I've now got access to BigQuery using the BigQuery admin permission, and I can pick my specific data set to continue the configuration and complete the environment setup. That concludes the video on how to install your hybrid Maia runner within Google Cloud Platform. If you want any additional help or assistance, you can go over to the Matillion support portal. Here you can search for different documentation and knowledge base articles. Also talk to our agentic AI support agent, which can also help you through the installation and setup. As well, if you need any more additional help, you feel free to raise a support ticket on the support portal. Thanks for your time. Hope you enjoyed the video.